Homework set number 3. In the first one, we would like to do a function that is going to count the number of primes between a given start and a given end. It will return the total number of primes. For example, between 10 and 20, there are only 4 prime numbers. There are some constraints here. You shouldn't use loops at all. You shouldn't try to use any of the built-in Python functions at all. In the second task, we will do a grid report. We did this task already before in the nested list task. So it's exactly what we explained before. There is a robot that can go only to the right or the bottom or the diagonal, and in each step it takes the maximum value. But this time we're going to implement this code using a recursive function. We are going to read the matrix, and then we are going to call a recursive function getPathSum with matrix, which is going to return for us the total path that the grid robot will take. In the third task, we are going to implement the standard maximum function. Now the logic of this function is very similar to the logic of like sum and left max function. It's very simple logic. So this task is actually not about recursion. It's actually more about software engineering. I would like you to get a sense of how strong is the maximum function, what kind of expectation you expect from it. Think of this as a good task for software engineering purposes. When we open the max function, you will notice the following. It seems that there are two ways to be able to call the maximum function. The first one is receiving an iterable, like a list, maybe set, maybe dictionary, and so on, something like we can iterate over it. And in the second one, it seems we can even pass like free variables like arg1, arg2, and so on. Now let's get in the details more. If you are passing an iterable, it seems you can even pass a default value. So this default value will be useful if the iterable is empty. In the case of the second one, it seems we have to pass at least 2 arguments, and you can also pass more than 2 arguments here. In both of cases, you can pass a function that is going to act like a key, a higher order function as we learned before. Now, thinking about what kind of errors would happen. What might happen if I passed an empty list without a default value? What could happen if only I passed a single value that isn't iterable? What would happen if I passed two default value, more than 2 values? Try to think about the different errors. I would like you to think like you are an engineer in a company and someone asked you to implement the max function. So you see the space of the flexibility, the default variables, all of that you should actually design. Now we are going to replicate this function to also learn how might be a bit hard to get it run to correctly match all of these different test cases. You are going to implement a function, let's call it my max. It's going to act like the max function as much as possible. Please make sure that you are almost getting all of these outputs. So here are the different test cases. My max of 2 and 5 is 5. This is now free variable. There is no list here. If you pass my max of a list of numbers, it will return the maximum, which is 60. If you pass the numbers without anything, like just asterisk args, it's going to find 20. You can also pass something like set. If you pass 2 items, each one of them is a list, then we have actually here list comparison. So the bigger list here is 5, 1. Now this is tricky. If you pass to the max function 1, 2, 3, 4 as a string, this is a sequence. This is a single item that is iterable. So it's going to iterate 1, 2, 3, 4 and return 4 for you. So be careful about that. But if you pass 2 strings, this is exactly like passing two lists here. It's going to compare string by string. So 1, 2, 3, 4 is less than 98. Now there is also a key function. A key will be used to compare based on the key. For example, if the key is the length, then comparing these two together, 1, 2, 3, 4 has a bigger length. In a similar way, the list 5, 1 and 4, 9 will return 4, 9 with the key sum because 4, 9 is bigger than 5, 1. Now let's see what's going to happen in terms of exceptions. If you try to call my max without any parameter, you will notice that you got type error, that at least one argument should be passed to match at least the list here. If you try to call my max without values but with a default parameter, you will get again the same error. Okay, but why the default wasn't used? because according to the API, the default here is only for the iterable case, but we didn't pass iterable so far. If you passed a max over a list that is empty, you get a value error that max arg is an empty sequence. Now you are passing something that is empty, so we cannot return a maximum. But if you pass the max with a list and a default value, it will return the default value. And see here, I can even pass a default value that is none. If I try to pass a default, a single value like -15, for example, you will get an error that this isn't iterable, because if it is a single parameter, it should be an iterable. If you try to pass two parameters that aren't of the same type, you will fail in the comparison. I would like you to implement a my-max function, consider the recursion as part of it, that is handling all of these test cases. This is a very good software engineering task that you might get in a company. For fun, if any time you would like to switch between your my-max function and the max function, you can just come here and uncomment this line, like my-max equal max will cancel your my-max definition and replace it with the max function, as we learned in the assign functions video. In the fourth function, homework would like to do a deep reverse. Remember that when you have a list like that 1, 2, 3, 4, 5, 6, and you try to do a reverse, it do a top level reverse. For example, it bring the 5, 6 here, 2, 3, 4 here, and the 1 here. So far so good. But what if we would like to do a deep reverse? What if we would like, even if we have a list of list of list, then every internal list got reversed? For example, here in this one, let's reverse it. We don't only get 5, 6 in the beginning. Even 5 and 6 are going to be flipped, reversed internally. 2, 3, 4 here, but 4, 3, 2, 1. 1 here. Let's take another example. 1, sublist 2, 3, 4, another sublist of 5 that inside it 6, 7, 8. So the one that have 5, 6, and 7, 8 will come in the beginning. But even its internal will be swapped. So now it's like 8, 7, 6, and 5. The 2, 3, 4 come here but swap. The 1 comes here. A bigger one, this guy. So the last one will come here and it also will be reversed. And then this one will come and reverse it. This one come and reverse it. If you try to read it, actually you will notice it. You can read it from right to left, like hey, 9.5, 9.5, 8, 8, 7, 7, 6, 6, 5, 5, 4, 4, 3, 3, 2, 2, 1, 1. You see, we have a very, very deep reverse. This function is an in place function. So this is your first task. In the second task, you will implement the same one, but first of all, it will be not in place. It's going to return a new deeply reversed list. The second constraint, I would like you to implement this function in only a single line that's going to do a complete deep reverse. In the last homework, we will do the Fibonacci. We already saw the Fibonacci a couple of times in homework before, but this time we are going to implement it. Notice that we can implement Fibonacci using a simple single for loop that is just maintaining the last two numbers, because Fibonacci of I is just the sum of the last two Fibonaccis. So 13 is just the sum of 5 and 8. 21 is the sum of 8 and 13, and so on. So we can make a single for loop that has the last two elements and keep doing them. But this time we would like to implement them in a recursive way. Now, observe the recurrence here is as following. Fibonacci n equal Fibonacci n minus 1 plus Fibonacci of n minus 2. For example, for n equals 6, Fibonacci 6 is actually Fibonacci 5 plus Fibonacci 4, which are the items from here. Now, I would like you to notice that this example is very different than any recursive example that we saw so far. This one has two recursive calls, not just a one. So it's actually have two sub-problems. When we have a factorial 5 and factorial 5 is 5 times factorial 4, you have a single recursive call. But this time we has two recursive calls. And this will raise up a very interesting observation. Can you compute something like Fibonacci 50 or not? If you cannot, there is a hint that I would like to give you from now. It is going to take a lot of time. Try to analysis and you will notice that a lot of computations are duplicated. Try to think how to save the intermediate result to solve this problem, if you manage to. If you manage to, welcome to dynamic programming. You just learned something interesting. That's all.